All right, thank you. Yes, after Chris's excellent broad introduction there, we'll start with our sort of first of the deeper dives into individual data sets, and I'll be talking about SkyMapper and in particular what you can do with SkyMapper DR4 with particular mind to the time domain aspects. So the fourth data release from the SkyMapper Southern Survey covers everything from the southern celestial pole up to a declination of about plus 15 over almost all the sky, with a few areas extending even further to the north. And from the 400,000 images, these aren't just single visits to cover the sky, but over the 7 years of the survey, in the six optical filters that we were using, we have many visits with a varying cadence. And with those repeat observations, you can then generate nice light curves for our Lyra stars or other variables, as shown in the lower right. Now, that distribution of visits from SkyMapper DR4 is a very magnitude dependent property. So in the first couple of years and then subsequently in bright moon periods, we were conducting the shallow survey, which reaches to about 18th magnitude in all the filters. And so sources brighter than 18th, between sort of 8th and 18th, will have visits from all of those observations. And the deeper observations of the main survey, also 5 or 6 visits per filter, then reach another few magnitudes deeper. And so for the sources that are brighter than 18th, you get the combination of those. And for the faint things that are fainter than that, you only have the observations from the main survey. In addition to those two main components of the survey, DR4 for the first time includes observations that came from other components. The largest of those is the SkyMapper Transient Survey, which was looking for supernova and other transient objects over 2,000 square degrees. And that's shown in the sort of patchy blue in the lower right-hand map. Now, they, of course, weren't surveying in such a patchy uh, cadence of, or patchy coverage of the sky, but uh, their observations were primarily conducted in bad seeing time. And so, with the quality thresholds applied to data release 4, many of those observations were not included in the data release. And so, we end up with a slightly more patchy coverage. In addition, in red in that sky map is 7 standard fields for which we have many thousands of repeat visits. And so at very bright magnitudes, we have many visits. At at intermediates, we have some additional coverage from the SkyMapper Transient Survey, and then we have fewer visits for the fainter objects. And this particular example shows you the properties of G-band, but if you then combine all of the filters together, the coverage then has this appearance where the number of observations goes up, summing across all of the different filters. Now, the particular visits that SkyMapper made to any particular piece of sky were done in a number of different modes, which yield then different cadences for the photometry. For the shallow survey, we cycled through all 6 of the SkyMapper filters in about 5 minutes. And so for a moving object like this main belt asteroid, you can see it moving its sky position. These were all centered in the same location. You can see it moving across the sky over that 5-minute period, and that's a bit easier to visualize with a moving object, but you get this similar sorts of variations for anything that changes its brightness within that span of time. For the main survey, there were 2 main observing modes. One was a color sequence, where we cycled through this set of 10 exposures. And so here again, for the same main belt asteroid, you can see it also moving again across the sky within that 20-minute span. And that was complemented then with the rest of the main survey being conducted primarily in filter pairs. So you can get usually you get at least two measurements of a single object taken within a very short time span from those observations. The other observations that made it into SkyMapper DR4 come from a wide range of observation cadences, from single images to monitoring a single field for hours on end. And so the distribution then in the observations of a single source that you're interested in will vary both by filter and also by sky position. Now, in terms of generating the data structure, the sort of logical progression is that the telescope takes images, and those images have CCDs, and on the CCDs you measure the detected objects, and then from those set of detected objects you measure properties of the actual astrophysical objects. But the way that you'll probably want to address the SkyMapper data set is by starting with those particular objects and working your way then to the individual measurements in the photometry table. And then if you need it, the properties recorded for the image as a whole. And we'll go through that in a little bit more detail. So the object table is known as the master table. We have unique identifiers. We have measurements of their average positions. We have stored the reddening, both the Schlegel maps and from the newer Planck satellite maps. We have sort of averages of what number of and types of observations do we have for that particular object. We have some measurements of how good those measurements were, what the most star-like measurement was, what the worst fit to a PSF model was. And then we have what most people would be interested in, the photometry in each of the 6 SkyMapper filters. And for point sources, that's a sigma clipped median PSF magnitude. But we also store the weighted mean of the aperture corrected magnitude within a 5 arc second diameter aperture. And we have the Petrosian magnitude, more useful for extended objects. And for variable objects, we include the range of magnitudes in each filter between the brightest and the faintest. In addition to those measurements for the objects, we've also cross-matched with the large number of external catalogs. So we match it internally to other sources, recording the offset distances to the nearest neighbors. We do that for Gaia, and then from the UV through a large number of optical catalogs and into the near-infrared and the infrared. Now, the detection table we label as the photometry table, and these record the individual properties of the measurements that we make from the images. Now, each image itself was given an image quality flag, from 1 being the best to 3 being the worst. The identifier in the photometry table is retained from the master table, so you can identify the particular photometry you want out of the table by using that object ID. But we had the individual measurements for the position, for the measurement flags, both either from source extractor or from the bad pixel mask. We then make measurements of the spatial distribution of the objects and the brightness, both in the PSF model and with various apertures. So if you want to find an object that meets a certain criterion, or whether that's at a certain sky position or if it has certain properties in the catalog, you probably want to start with the DR4.master catalog. If you know what object ID you're interested in, or if you have a particular sky position, then you can go directly to the DR4 photometry catalog and get the individual measurements. And for reasons I'll mention in a moment, you may want to join that with the DR4 images table. So Chris already gave a brief introduction to the SkyMapper website, through which you can access many of these things. I'll focus more on what you can do through Topcat and through other tools. Topcat, if you aren't familiar, lets you conduct a large number of interactions with external data sets. You can do manipulations of tables you've stored locally, and it has a great variety of functions to allow you to do plotting. So for Topcat table queries, to access the SkyMapper data, you can go to their table access protocol tab. That will pop up this window. If you search for SkyMapper, SkyMapper's website will be the top one that comes up. You just have to hit use service, and that will take you to the next panel in this same window. And you'll see a variety of folders there for the different data releases that we've made over the years. And the organization of those tables is usually within a group, a schema, for a particular data release or for the external catalogs we have available, and then with a table name. You can access the particular descriptions of all of the rows and units and more details by clicking on the particular tables that you're interested in. To conduct a query of the service, we have a number of examples. I'll mention that you can change the query mode here. Synchronous has a very short timeout, and so if you have anything more than a very simple query, you'll probably want to use the asynchronous query mode. One of the examples we have is to do a coordinate query, and I'll just note that the sort of typical RA deck, the ICRS format is the only one that the service understands, so don't try to mix and match with galactic coordinates. When you make these asynchronous queries, you can come back and retrieve the result later. You just have to make sure that you come back and retrieve the result within 24 hours of it being submitted. So moving ahead, if you want to generate a light curve for a particular object, let's say you know the object ID, it's quite simple to generate a light curve. You can put this query into your tap query. It will very quickly generate a result. You can then use Topcat's plotting tool, and you may want to include here, we have joined the images table to the photometry table because the images table is the best source of the MJD, the date of the observation. And so by running that query, you can then easily plot the date versus the magnitude, and we get something like this for this particular object ID. So that looks a bit peculiar, ranging by half a magnitude within a fairly short space of time. So let's flip the magnitude axis here and note that a query like the one I showed you gives you everything, even the unreliable measurements. And there are a few ways you can try to select out the good data. Here I've color-coded in the Form tab. I've color-coded by the use in clipped measure. So use in clipped can take on three values. One is a good value, a good measurement from the image, which we've used in generating the average value in the master table. If it was clipped as an outlier, it will have a using clipped value of 0. And if it's just a bad measurement, it'll have a using clipped value of -1. You can see here in the color coding, all of these very bright measurements over here in later times have a using clipped value of -1 because those are deeper images and this bright source was saturated. Now, it turns out that this source, which I picked for just being blue and bright and having a number of measurements, turns out to be a galactic emission line B star. And as we see here, it has a G-band magnitude range of sort of 10.3 to 10.5, and that's very similar to what was found by other surveys. So the way that I actually found my way to this paper was on the object viewer page for this object, clicking the Simbad link, and then following the directions to the references in Simbad gave me this nice light curve to compare to the SkyMapper one. So there's a number of additional ways of accessing the data, which I'll just touch on very briefly. You can do it through PyVO, and these services are working. The underlying facility that runs all of these services in the back end had been undergoing maintenance today. It's now back online, so you should be able to run queries like this yourself. The photometry table is available through the Astro Data Lab if you want to be able to upload your own large tables and cross-match across the variety of large tables that they have in their database. We've just recently been sharing the photometry table with LSDB, which is a sort of a Rubin-oriented system that is developing sort of new data formats and new ways of storing data to be able to quickly cross-match between catalogs. And if you only want to cross-match the master catalog, that's available through a wide variety of places. You can even do that with this fast CDS upload cross-match within Topcat. And we're in their drop-down menu, and that will get you a very quick indication of what objects that you're interested in have SkyMapper data. And I'll be happy to take any questions.